Hello, I'm Shawir Sadeghi and I'm a PhD student at the University of Windsor presenting Whitening Not Recommended for Classification Tasks. Sentence embedding plays a fundamental role in NLP. Despite the widespread success of large language models in generative tasks, embeddings obtained from pre-trained models are not impressive. Sometimes they are not even competitive with traditional word-to-vec based approaches on machine learning tasks such as classification and semantic text similarity. Hence, there has been many research aimed at improving the quality of embeddings based on large language models. One of them, which is the post-processing step, is whitening. Whitening has been shown to be an effective method for improving embeddings obtained from large language models. However, we find that the efficiency of whitening is both model dependent and task dependent. More specifically, whitening degrades embeddings for classification tasks. To further verify our result, we explore a variety of whitening operations, including PCA, ZCA, and Cholsky whitening. A byproduct of our research is an embedding evaluation platform for LLMs, which we call CentEval Plus. Large language models are big and costly to run. CentEval works well on smaller models to help the evaluation of large language models on commodity machines. We provide pre-calculated embeddings. There is not much detailed comparison of the performance of embeddings from OpenAI, maybe partially due to the cost of API calls. We observe that the embeddings from OpenAI are overall comparable with Llama. Another interesting observation is that Llama and Llama 2 are very close in terms of embedding performances. Whitening transformation, as you can see in this algorithm that we have here, has this main matrix called W that you can see in equation number 1. We have 5 different whitening matrices, which the top 3 are based on the covariance matrix, while the bottom 2, which means ZCA correlation and PCA correlation, are based on correlation matrix. Once we have this whitening matrix, we just can simply multiply our centered embeddings with this whitening matrix and have our whitened embeddings. For our experiment, we use CentEval Plus, which has 2 main steps. One is embedding generation, which we generate embeddings for given datasets and store them. Second is embedding evaluation. We pick 2 tasks, semantic similarity, which for that one we use Spearman correlation value, and next one is text classification, which we use accuracy for our metric. For text classification, we have some specific settings that we follow from CentEval. We use MLP with no hidden layer. For our optimizer, we use RMS prop. Our stopping criteria is maximum number of times the validation error does not decrease, which is equal to 3, and we use 3 epochs and nested tenfold cross-validation. And you can see our GitHub link at the bottom, which is for CentEval Plus. We use 8 different embedding models, including expert, angle optimized embeddings, SimCSE, Llama, Llama 2, BERT, and ChatGPT. For expert, angle optimized, and SimCSE, we download and generate embeddings using library APIs. While for Llama and Llama 2, we download 7 billion model from Meta and then load from transformers. For BERT, we download and load from Hugging Face and transformers. For ChatGPT, there is not much you can do, and you don't have access to the model, so you can simply generate your embeddings using APIs. And here we have the overview of our embeddings settings, including the pooling settings, whether we use GPU or not, their dimensions, and how we can access to these embeddings. For examples, following SBERT, we use the last layer for pooling um, for BERT and Llama, while SimCSC, Angle Llama, and Anglebird use CLS. For dimensions, the BERT-based models have the same dimensions, while the Llama-based ones have similar dimensions. We can see that for SBERT, SimCSC, and Anglebird and Angle Llama, we use library. For ChatGPT, we use OpenAI API, and for BERT, we use Hugging Face plus transformers, and for Llama, we use Meta plus transformers. This is the result of our classification tasks. As you can see, the pattern is very similar in all the data sets. With and without whitening, comparison in this plot shows that with whitening is always lower than without whitening. It also shows that the changes of our whitening method overall doesn't impact the result of whitening. It also shows that because we sorted our models based on their uh, embedding size, you can see the gap between with and without whitening increase as their size of their dimension of their embeddings increases. For a better visualization of this gap, we also plotted the delta of these with and without whitening. As you can see, this is always decrease. The decrease is less for models that have lower dimensions size, and a lot higher for models with higher dimensions, since Angle Llama, and Llama 2 have over 4,000 features. As for our SCS result, we have notable improvement on vanilla large language models like BERT and Llama, while we do not see any improvement for the other methods which are fine-tuned. We also understand that the whitening method does not impact the result as much. We also looked at the isotropy metrics. Since whitening improves the isotropy, and you can see it in this plot that the improvements before and after whitening, isotropy always improves. However, our experiments indicate that the improvement of isotropy does not imply a performance gain in classification tasks. We also plotted the PCA presentation visualization of our with and without whitening of all our 8 models versus their whitenings. And we also have we got the 5 different whitening operations on one of our embeddings, which is ChatGPT. Overall, we show that the performance of whitening is model dependent and task dependent. For classification tasks, we do not recommend to apply whitening. For STS tasks, the performance varies from model to model, and it works only for large language models before fine-tuning. Also, technical details of ChatGPT remains to be a mystery. Based on its reaction to the whitening operation, we can infer that it may be fine-tuned, probably using NLI data. Thank you for your attention.